Welcome to Topic 3, Lesson 3, Text on Rocks. Please turn to page 128 in your book if you haven't already done so. My expectation is you are following along as I read. Our guiding questions: what are the three major types of rocks and how do they form? How is the formation of rocks the results of the flow of energy and cycling of matter within Earth? Our vocabulary: igneous rock, sedimentary rock, sediment, metamorphic rock, apply. Before we begin reading, I'd like to take a look at our Connect It. It says, draw an outline of what the weathered rock may have looked like 2,000 years ago, and then answer, how do you think the rock formation will continue to change over time? So that might mean you take your pencil and you draw, I think the rock looked like this 2,000 years ago. That's okay. And then I could write, in the future, and answer what you think the rock will look like in the future. Please push pause here, do those two things, and then you're ready to play again. Thank you for coming back. Now, on to paragraph 1, describing rocks. Please follow along as I read. In southern Utah, spires and buttes of red sandstone rise up into the sky. In Monument Valley, Figure 1, to a tourist or other casual observer, these rock formations seem to stand motionless and unchanging, but every moment of every day, forces are at work on these rocks, slowly changing their shapes and sizes. Weathering, erosion, transportation, and deposition all work to wear away and alter the appearance of the rock formations. Alter, as we talked about in our last lesson, Lesson 2 on minerals, means to change. Let's take a look at towers of rock, Figure 1. The striking red color of Monument Valley is the result of iron oxide minerals exposed within the rock. Paragraph 2. Rocks like the sandstone in Monument Valley are made of mixtures of minerals and other materials. To describe rocks, geologists observe mineral composition, color, and texture. And I would actually like you to highlight or underline that last sentence. That's going to be an important one for us throughout this lesson. Moving on to page 130. Paragraph 3. Mineral composition and color. Some rocks contain only a single mineral. Other rocks contain several minerals. About 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals. Paragraph 4. A rock's color provides clues to the rock's mineral composition. Granite, as shown in Figure 2, is generally a light-colored rock that has high silica content, meaning it is rich in the elements of silicon and oxygen. Figure 2 over here, we can see it talks about it. Granite is generally made up of only a few common minerals. This coarse granite formed when magma cooled slowly. You don't have to go down here quite yet. We'll talk about that a little bit later. Also, granite is something you will commonly see around Minnesota. Paragraph 4. I'm sorry, I just read that. Paragraph 5. Texture. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. To describe the texture of a rock, geologists use terms that are based on the size, shape, and pattern of the grains. For example, rocks with grains that are large and easy to see are coarse-grained. In fine-grained rocks, grains can be seen only with a microscope. Paragraph 6. Origin. Using mineral composition, color, and texture, geologists classify a rock's origin, how the rock formed. Geologists have classified rocks into three major groups based on origin: igneous rock, sedimentary rock, and metamorphic rock. Reading check. Determine meaning. Igneous means fire in Latin. What is fiery about igneous rocks? Take a moment, pause, and write in what you think is fiery about igneous rocks. Page 131, paragraph 7, how rocks form. Each type of rock, whether it's igneous, sedimentary, or metamorphic, forms in a different way. Paragraph 8, igneous rock. Rock that forms from cooled magma or lava is igneous rock. Igneous rocks can look very different from each other. The temperature and composition of the molten rock determine the kind of igneous rock that is formed. Paragraph 9. Igneous rock may form on or beneath Earth's surface from molten material that cools and hardens. Extrusive rock is igneous rock formed from lava that erupted onto Earth's surface. Basalt is kind of a tough word, looks a little funny. Basalt is the most common extrusive rock, making up a large part of oceanic crust. Igneous rock that formed when magma hardened beneath the surface of Earth is called intrusive rock. So extrusive, it's outside the Earth. Intrusive, it's inside the Earth. The most abundant type of intrusive rock is the continental crust. On the continental crust is granite. Granite forms tens of kilometers below Earth's surface and over hundreds of thousands of years or longer. When granite ends up close to the surface, it may be mined for use as road building material in a crushed state or as a building material in large polished slabs. Paragraph 10. The texture of most igneous rock depend on the size and shape of its mineral crystals. Rapidly cooling lava found at or near Earth's surface forms fine-grained igneous rocks with small crystals and no minerals at all. Slowly cooling magma below Earth's surface forms coarse-grained rocks such as granite and diorite with large crystals. Intrusive rocks have larger grains than extrusive rocks. Extrusive rocks that cool too quickly to form any minerals are called glass. Take a look at Figure 3, igneous rock formation. Figure 3, the texture of igneous rock varies according to how it forms. If I look here, we're going to fill this out in a little while, but take a look. It says diorite, a very coarse-grained intrusive igneous rock. And then it says rhyolite. Rhyolite is a fine-grained extrusive igneous rock with a composition that is similar to granite. And it's actually asking you to match up where the letters go, which one matches with which. And we'll do that a little later. Page 132, paragraph 11. Please make sure you're still following along. Sedimentary rock. Most sedimentary rock forms when small particles of rocks or the remains of plants and animals are pressed and cemented together. The raw material is sediment, small solid pieces of material that come from rocks or living things, as shown in Figure 4. Sediment forms and becomes sedimentary rock through a sequence of processes: weathering and erosion, transportation, deposition, compaction, and cementation. Examples of sedimentary rock include sandstone, shale, and limestone. Take a look at Figure 4. We will take a look a little bit later when we do some of our notes. It says, sequencing sedimentary rock formation. Sedimentary rock forms in layers that are then buried below the surface. Formation occurs through a series of processes over millions of years. We've got weathering and erosion. Rocks are broken down by freezing and thawing, organisms, and other forces. Rock fragments are carried away by water, wind, or ice. Transportation. Eroded material can be transported by wind and water far from its origin. The material can be weathered further as it is transported from place to place. Deposition. Sediment settles out of water or the wind into layers. Compaction. Over time, the layers of sediment are squeezed and compacted under the weight of layers above. Cementation. Dissolved minerals glue compacting sediment together. Page 133. Paragraph 12. Metamorphic rock. Metamorphic rock forms when a rock is changed by heat or pressure or by chemical reactions. When high heat and pressure are applied to rock, the rock's shape, texture, or composition can change, as shown in Figure 5. Paragraph 13. Most metamorphic rock forms deep inside Earth, where both heat and pressure are much greater than at Earth's surface. Collisions between Earth's plates can push rock down toward the deeper, hotter mantle, altering the rock. The heat that changes rock into metamorphic rock can also come from very hot magma that rises up into colder rock. The high heat of this magma changes surrounding rock into metamorphic rock. Paragraph 14. Very high pressure can also change rock into metamorphic rock. When plates collide, or when rock is buried deep beneath millions of tons of rock, the pressure can be enough to chemically change the rock's minerals to other types. The physical appearance, texture, and crystal structure of the minerals changes as a result. Paragraph 15. Metamorphic rocks whose grains are arranged in parallel layers or bands are said to be foliated. There's the word foliated. For example, the crystals in granite can be flattened to form the foliated texture of, and this is a strange word, it's pronounced gneiss. Some metamorphic rocks, such as marble, are non-foliated. Their mineral grains are arranged randomly. Take a look. It says the heat and pressure can change one type of rock into another. Label each rock sedimentary, igneous, or metamorphic. Indicate whether the metamorphic rocks are foliated, then shade the correct arrowhead to show which rock can form from the other rock. And you don't have to worry about this right now. We'll take care of that a little bit later together. Paragraph 16. The flow of energy. No matter what type of rock is formed, it is formed as a result of the energy that flows through the Earth's system. The energy that drives forces affecting the formation of sedimentary rocks such as weathering, erosion, transportation, and deposition comes in the form of heat from the sun. Right now, take a moment and underline that sentence starting with the energy that drives forces affecting the formation of sedimentary rocks such as weathering, erosion, transportation, and deposition comes in the form of heat from the sun. Heat from Earth's interior drives the processes that control the formation of igneous and metamorphic rocks. Now, hopefully, you've been doing a great job of listening to the book and following along. Figure 6, eruption. Now, what you are going to do is on your Post-it note, write the word eruption. When you're done listening to Figure 6, you're going to bring that Post-it note up to Mr. Reuger. You're going to hand it to him, and he'll give you your notes. You can then use your book to fill in your notes. Good luck. Figure 6, a volcanic eruption brings up magma that will be subject to weathering and erosion when it cools. Make sure you don't tell anyone else what you're writing on the Post-it or why you're bringing it up to me. The group that does it the best may get some extra bonus points. All right, thanks for listening and following along. Please now take care of that Post-it note.